packets. A famous production incident at a large social media company highlighted the danger of using 32-bit sequence numbers, which wrapped too quickly, causing chaos. Finally, adaptive protocol switching is key. Network conditions are rarely static. Your system should dynamically switch to TCP if packet loss exceeds a threshold, say 5% over a 60-second window, and then intelligently attempt to switch back to UDP when conditions improve, using an exponential backoff to prevent rapid, destabilizing oscillations. This prevents alerting fatigue and maintains throughput. To truly maximize UDP's potential, we need to talk about efficiency and resilience. First, batching and framing are essential. UDP's maximum transmission unit, or MTU, is typically around 1,500 bytes. By packaging multiple log events into a single UDP packet, you amortize the per-packet overhead, significantly improving network efficiency. Your framing strategy should include a batch size and sequence number, followed by individual message lengths and data. The trade-off is that larger batches increase the blast radius of packet loss. Losing one large packet means losing many events. Benchmarking often shows 10 to 15 messages per packet as optimal for typical log sizes. Second, server-side load shedding is critical. High-throughput UDP servers can overwhelm the kernel's receive buffer, silently dropping packets before your application even sees them. You must proactively tune your operating system's UDP receive buffer size, for example, increasing net.core.rem max on Linux. Beyond kernel tuning, implement application-level load shedding. Track your processing queue depth, and if it exceeds a threshold, send a negative acknowledgement, or NAC, back to the client, signaling them to slow down or switch protocols. This is how major cloud providers handle massive ingestion spikes without over-provisioning. Bringing it all together, let's look at what truly matters in production. In high-throughput scenarios, UDP consistently outperforms TCP by 400 to 500%. However, this performance degrades non-linearly if your kernel buffers overflow, so continuous monitoring of REM max utilization is essential. For monitoring, focus on key metrics: your packet loss rate, aiming for less than 0.5%, your messages per second throughput, and the UDP versus TCP protocol distribution to understand your system's adaptability.